Hey guys, welcome to another video for anatomy and physiology. In this video, I'm going to be talking about muscle contractions. So muscle contractions are basically four major phases for it. And as I am recording right now at this very second, I'm not sure if I'm going to make four separate videos or this is going to be one long video. I'd rather not have a really long video, but at the same time, I'd rather have all the information at one specific location. So we'll see. We'll see how I end up editing this. But in any case, like I said, there's going to be four major phases for muscle contraction. And these are the four phases. You have excitation, contraction, coupling, and then the actual contraction of the muscle, the shortening of the belly of the muscle. And then you have the relaxation phase, where the elongation of the muscle. So let's go ahead and talk about that first phase. The first phase is essentially 5 steps, and that's excitation. Okay, so excitation, contraction, and then relaxation. So I'll be breaking each one of these up into separate phases, separate steps. That is, each phase will have separate steps. So as I mentioned, there's essentially 5 steps to this. And the first one that we're looking at here, again, is excitation. So what you see here, the red arrow, and you have that little triangle there, that synaptic knob. So that synaptic knob represents the neurotransmitter, the muscular neuro connection junction, which that means this is where the nervous system, the nerve connects, comes into contact with the actual muscle fiber. So muscle fibers all basically are connected to the nervous system in some way. Now, muscle fibers that we're talking about here are skeletal muscle. This is muscle that you have conscious control of. So for example, right now you open your hand and close your hand, you have conscientious control of those muscles in the hand and then the fist. When you're throwing a ball, when you're flexing your muscle, when you're flexing a bicep and you're picking something up, you have conscientious control of all of this. So we're talking about striated muscle here. So again, so this is all connected to, there's a connection between the muscle, a nerve connection and a muscle connection, and this is where the rubber meets the road, if you will. So the synaptic knob is the nerve ending at the end of the long nerve that connects to the muscle fiber, and each muscle fiber has, a set of muscle fibers has a synaptic knob, a connection with the nervous system. What you have is you have the action potential from the nerve running down the axon, going into the synaptic knob. So this is the nerve signal. Okay, now when the nerve signal reaches the synaptic knob, what happens is you have calcium ion channels that will open up, and calcium will go inside of the synaptic knob. Remember, calcium +2, if you remember that from chemistry, that means that there's a lack of 2 electrons, right? So that's why it's got a +2 charge. So these calcium ions will enter the synaptic knob, and so what's going to happen is you're going to have a cascade of reactions. So one thing will beget the other, and then the other, and it just kind of, it kind of trickles down to ultimately a muscle contraction. So the nerve signal reaches the synaptic knob, calcium goes inside of the synaptic knob, and those calcium ions stimulate acetylcholine. Okay, this is a neurotransmitter. This is the molecule that makes the connection between the nervous system and the muscular system. So these neurotransmitters, these acetylcholines, are in synaptic vesicles. They're kind of in this little protective case, if you will, in the synaptic knob. And when the calcium goes in, it initiates the acetylcholine to be released. So the acetylcholine now is inside the synaptic cleft, and it's about to make contact with the muscle fibers. Okay, so now we're having a neuromuscular connection here. This is acetylcholine jumping in, and they're going to bind with these acetylcholine receptors. These are called ligand regulated receptors. Ligand meaning these receptors, these channels are initiated only by other molecules. Okay, so again, acetylcholine will go through the synaptic cleft. And now we're kind of zeroed in on the ligand channel here. So let me back up. So all those blue rectangles, so we're zooming in on what's happening there. So something to make note of real quick. So in the synaptic cleft, there is a specific charge difference between that and the sarcoplasmic reticulum of the muscle. And it's a difference of 90 millivolts. So it's a -90 charge. So that means that the that the yellow portion, if you will, the sarcolemma, has a charge differential of 90 millivolts. So the orange part, if you will, is more positive than the white part, the synaptic cleft, okay, by negative 90 millivolts. So if you ever watched a video of neurotransmitters that I made, you probably haven't because we haven't had this topic yet in A&P yet, but one of the easy ways to remember, sodium or potassium, which one is on at which level. Think of a salty banana. Okay, so think of a banana and then pouring salt on it. So salt, is sodium chloride, right? And then bananas are filled with potassium. So the salt is on top, so sodium, and then banana, potassium on the bottom. So a salty banana. So when this junction here is not stimulated, you have a higher concentration of sodium in the synaptic cleft and a higher concentration of potassium in the sarcoplasmic reticulum. And this concentration, this differential, has a negative 90 millivolt concentration. So that being said, now that you have the neuron being stimulated, acetylcholine, the neurotransmitter, has been released, and it's traveling across the synaptic cleft. It's about to bind with our receptor, and as it binds with that receptor, this channel opens up, and now sodium and potassium switch places. They rush to the opposite side. They rush with the concentration gradient. So there's less concentration of sodium at the bottom, so sodium rushes down, and the synaptic cleft has a lower concentration of potassium, so the potassium rushes in. And once this exchange happens, essentially you have now the charge in the synaptic cleft changes, and it changes into a more positive charge. So now you go from having a negative 90 millivolt difference to having a positive 75 millivolt difference. This is called the end plate potential differential. So now what's happened is that your potential, your charge difference has changed, and this is going to actually initiate something else. This is basically the last step of the excitation stage. So actually, let me back up a little bit. Well, actually, yeah, right there. So what I don't have shown also is that we have sodium potassium pumps that are not ligand regulated, but they are voltage regulated channels. And what will happen is that once you have this differential of charge happen, now once the synaptic cleft is at a positive 75 millivolts, what's going to happen is that all the channels that are on the outer edges, the sodium potassium channels, those now get woken up, they get initiated, and now you have an even more a higher exchange of sodium potassium. And what that's going to end up happening is that's going to create a cascade of a charge. That's going to create an action potential. So again, if you're looking at the top, those are the acetylcholine receptors. So picture what just happened. Acetylcholine binds to those receptors, and across the sarcolemma, which is our outer layer, is again sodium potassium pumps. Once those get initiated because of the change in charge of the synaptic cleft, then you're going to have a cascade of potassium going into the T tubule, and that's essentially the action potential. All right. So that action potential is actually the next phase of what we're going to talk about, which is the excitation contraction coupling. Okay. So let me back up. Okay, so this again was the last stage of our excitation, which means this is the initial start of every muscle contraction, which is a charge differential that occurs on the synaptic cleft via acetylcholine binding to the ligand channel receptor, causing the potassium sodium exchange, which causes the voltage change. Okay, guys, I know this was quite a bit, but again, this is only the first phase, so just kind of keep this in mind, keep studying. Remember that this is a cascade of reactions that occurs, and ultimately ending up in a muscle contraction. So I hope this video helped. Thanks for watching, guys, and good luck in your studying.